there?
Madhvi ma'am.
It is there. Good morning. Okay, done. Good morning, students. Okay. Good morning, Mahadeva, Kirtana, Kritik, Anaro, Harini. So good morning to everyone. Good morning. So we will wait for 1 or 2 minutes. Then we will start. Today I think you guys should be very attentive because it's not hot outside. It was raining, right? So Manjushri, Manjunath, yes, good morning. Manvit, Shravya. I have a doubt, Shravya. Why your name is Shravya? Why 2 times? No, simply I am asking. Then Rohan rocks. Oh. So good morning. Okay. So by the time others will join us, what I will do is, as usual, I will give a brief view of whatever has been taught in the last class. Fine. So we have discussed about a disaccharide called as lactose. So what are the monosaccharides present in lactose? Our question can be, name the disaccharide when lactose will be hydrolyzed. So which is that one? That one will be galactose and glucose. Anyway, this has been done day before yesterday. Then we have done with the maltose. So now the question will be same. Which are those monosaccharides which will be released when maltose will be hydrolyzed? So that will be glucose and glucose, because maltose is made up of alpha D glucopyranose and alpha D glucopyranose, right? So that's what yesterday we have discussed about maltose. So good morning once again. Some more students, the people have joined. Good morning once again. So now that's where we have discussed about the maltose. Fine. Now next, what else we have discussed? We have discussed about the polysaccharides. So we have discussed about the polysaccharides. So polysaccharides can be homopolysaccharide or heteropolysaccharide. Now when it comes to homopolysaccharide, once again we have linear and branched. So linear and branched polysaccharide. So when it comes to linear, we have discussed about cellulose, which are present in the plant cell walls, which are the important component of the dietary fibers, right? So that's where we have the cellulose. So cellulose is having beta 1,4 linkage, right? That is important, where glucose will be linked by beta 1,4 glycosidic bond. That's what we have discussed about the cellulose, which is an example for linear polysaccharide. Now when it comes to branched, so we have discussed about starch and glycogen. Now when it comes to starch, as we have discussed, it is having 2 components. One is amylose and another one is amylopectin. If I take amylose as an individual polysaccharide, then it is a linear polysaccharide. Amylose is a linear polysaccharide, but amylopectin is the branched polysaccharide. So due to the presence of amylopectin, starch will be considered as a branched polysaccharide. Fine. So that's where we have the starch, which is a plant storage polysaccharide. Fine. It is found in the plants. Next is glycogen, which is also called as animal starch. So which is also called as animal starch. So why it is called as animal starch? Because it is also a storage polysaccharide just like starch. So therefore it is called as animal polysaccharide or animal starch. So which is present in the animals. Now that's where we have starch and glycogen as a storage polysaccharide. When it comes to structural features, glycogen is similar to that of the amylopectin. Only difference here is glycogen is highly branched and amylopectin is less branched, right? So that's what we can see here, the difference with respect to amylopectin and starch. But otherwise, both of them, they have alpha 1,4 and alpha 1,6 glycosidic bond. Amylopectin and glycogen, both of them, they have alpha 1,4 and alpha 1,6 glycosidic linkage. Wherever branch point is there, at that particular branch it will be alpha 1,6. Rest of the linkage will be alpha 1,4 only. Fine? So that's what we have discussed with respect to polysaccharide. Branch polysaccharide. Okay? So this is with respect to carbohydrates. Now then we have started with the proteins, where I was talking about importance of the proteins. Right? So that's what we were talking about, importance of the proteins. Now when it comes to proteins, as I told, they are the important component of the muscles. If there will be a shortage of protein, a person is not going to survive, which is not happening. That's how our body is maintaining the protein level. It will try to maintain, right? So that's where we have the importance of the protein. It is present in the formation of tissues like muscles. In the same way, it is also present as enzymes in our body. Almost all the enzymes except few cases, we have the enzymes which will be of proteins. Then many of the hormones, they are nothing but proteins. That's what I mean to tell. That shows the importance of the proteins, right? Even they are present in the cell membrane. For biology students, we have seen fluid mosaic model, right? So where we have studied that there will be a proteins, transmembrane protein and peripheral proteins. So that shows proteins are present also in the membrane, right? So they will function as a receptors on the surface of the cell. That's what I was telling in the last class. Glycoprotein, when I was talking about the importance of the carbohydrate, I was telling about glycoprotein. So glycoprotein means what? Glycoprotein means where protein plus carbohydrate both will be there together. So that's where we have proteins everywhere. Most of the biological function will be carried by proteins. Fine? So that shows the importance of the protein. Fine? Now I am going to discuss about, before starting with the protein, we should understand its component or building block. If someone asks you, what are amino acids? If someone asks you, what are amino acids? Yes, you are telling good morning sir, but at the same time you are crying, or due to lots of this one you are getting tears. Huh? Now simply I was asking, good morning to everyone. Fine? So Akash, 2 times you have told. So I am also telling good morning. Fine? So that's where we have the amino acids. Now when I am talking about amino acids, if someone asks you what are amino acids, then you should tell that these are the molecules. Okay, these are the molecules which are the building blocks of proteins. These are the molecules which are the building blocks of proteins. Say for example, to construct a house, we will be using bricks, right? So one brick over the another brick, and like that bricks will be there. So these bricks you should imagine as a amino acid, and the whole building you can consider it as a protein. So that's where that is the relation between a protein and the amino acid. If I remove the bricks, whether building will be there? No. That's where it is called as, amino acids are called as building blocks of proteins. Fine. Now, whenever we are putting bricks, whether you are simply keeping bricks as it is or we are using some cement and all, we are using it, right? So therefore, in amino acid also, in the protein, these amino acids has to be linked with each other. That work of cement, in this case it will be taken care by the peptide bond. There is a covalent bond which are present between the amino acids. Anyway, that one I will come later. Before going for that, that's where we have the amino acids, which are the building blocks of protein. That's what you can write if someone asks you to define amino acid. Fine. Now, if I want to see the structure, in the name itself it is there, amino acid. Now, whenever we are talking about organic chemistry, acid indicates what? Acid indicates the functional group, which is that one, carboxyl functional group, right? Carboxylic acid. So that's what this acid word indicates, that there is a presence of carboxyl functional group. Yes, Ravikant, very good. COOH, right? So that's where we have the carboxyl functional group. We have to put one line. If you simply write carboxyl group as it is, it's not very correct, because always it should be written like this. If you observe it carefully, carbon should have the 4 bonds, right? But here it looks like I have written like this, which is not correct, because only 3 bonds I am showing. So same logic is applicable for in aldehyde also, where you should mention CHO or COH, anything is fine, but this line should be there. Fine, that's fine. So that's where we have the carboxyl group, right? Now amino, what do you mean by amino group? That means it is ammonia derivative, not ammonia as it is. Ammonia means it will be NH3, right? So here it will be NH3 or NH2. We'll go with NH3. Now when I am talking Pratik, yes, NH2, then amine, then it will be ammonium. I will tell why it will be ammonium. Now nitrogen with how many bonds? Here nitrogen with how many bonds? When it comes to ammonia, nitrogen is forming 3 bonds. When it comes to amine, it is nothing but once again 3 bonds. So this is amine, this is ammonia, right? So in that case, here how many bonds are there? 4 bonds. 3 of hydrogen with another one I have written here. So I will mention this one as plus, because whenever nitrogen will make the 4 covalent bonds, that means tetravalent condition, nitrogen should carry positive charge. Ammonium NH4 plus ammonia NH3, right? So that's where we have the amino derivative in the form of ammonium. Fine. So when it will be NH2, I will tell Manjushri and Pratik. Yes. Fine. So in that case, these 2 functional group will be attached to 1 carbon. These 2 functional group attached to same carbon. So therefore they are called as amino acids. Right? Now other 2 components will be, one will be hydrogen and another one will be R. What is that R? R means Raghavendra. Right? So what do you mean by R? R indicates it is variable. It varies from one amino acid to another amino acid. Therefore, they are called as side chain groups. They are called as side chain groups. Okay? So it is variable, it is not constant. It varies with amino acid to amino acid, because in the nature we have around 20 amino acids. In the nature we have around 20 amino acids. All these 20 amino acids will have this one constant. All of them, they have this one constant. All of them. All the 20 amino acids, they have COH, NH3 plus and hydrogen attached to the carbon. So that's where it is constant. Variation is with respect to R. So based on the type of R, we have 20 amino acid. Fine. Say for example, simple amino acid I will take COOH, NH3 plus, hydrogen, hydrogen. R will be equal to hydrogen in this case. R will be equal to hydrogen. That means I am talking about glycine. I am talking about glycine, one of the smallest amino acid among 20. Glycine, where R will be nothing but hydrogen. Right? Same way, if I take another one, remember the glycine structure, other amino acid not required. So NH3 plus, if it is CH3, methyl group. If it is a methyl group, then it will be considered as alanine. Then it will be considered as alanine. So what I mean to tell here is, depending on the R, depending on the type of R, there will be variation. Right? So depending on the type of R, there will be variation. Yes, Aishwarya, I have forgotten to put one line. Yes, hydrogen, where R will be equal to hydrogen with one bond. Yes. Then alanine. Yes. If it is methyl group, if it R is equal to methyl group, then it is called as alanine. Like that we have total different 20 amino acids. Okay. Before going for that, first we will go with the structure, general structure of amino acid. Now, one of the important question, one mark question which you can expect here is, write the Zwitter ionic form of amino acid. Write the Zwitter ionic form of amino acid. Fine, that will be the question. Zwitter ionic form of amino acid. That can be one question. Now, if they have asked about amino acid, then you can use this structure. Sometimes they will ask, write the Zwitter ionic form of glycine, then you should go for this. Anyway, whatever I have written, it is not a Zwitter ionic form, but do you agree? Whatever I have written in the box, it is constant. You can see here, for alanine also it is there, for glycine also that part is constant. So therefore, whatever I have written inside the box, they are actually constant. It will be present in all the amino acids. That is one point which you should remember. Okay? So next here is, you should tell me that whatever I have written, before going for that you should tell me that carboxyl group, it is called as acid functional group. Right? So carboxyl group will be called as acidic functional group. What is the reason? Why carboxyl group will be considered as acidic functional group? Anyone? Why carboxylic acid will be considered as acidic functional group? No other functional group other than carboxylic acid and sulfonic acid. Only these two will be considered as acidic functional group. Now we will not go with sulfonic acid. Since we are talking about carboxylic acid, we will stick to that. So therefore they will end up with acid. So why? They are called as acidic functional group. Before going for that, what are acids? Anyone? Very basic question. What are acids? Hmm? Anyone can give the answer? What are acids? Chemical equilibrium, you people have studied. pH, everything you people have studied. What are acids? Any answer? Okay. Electron pair acceptors. Very good. Krishna. Okay, fine. Mayank has written electron pair acceptor. Then which can give hydrogen ion. Very good. H plus. Which can give hydrogen ion. No doubt. Even they are called as acid. H plus donors. Very good. So it can be electron acceptor, it can be OH minus acceptor, or it can be H plus donors. In all the cases they are considered as acid. Now if you observe, carboxylic acid is one of the molecule or functional groups where it can easily donate the H plus and it will become carboxylate. So whatever I have written here is carboxylic acid. Whatever I have written here is ionic form, that is carboxylate. 8, that talks about anion. ATE, carboxylate. If anything with IUM, ammonium, sodium, IUM it is there, we are dealing with the cation. So here AT is there, therefore carboxylate, right? So carboxylic acid, by releasing one H plus, it is becoming negatively charged. That's why it is called as carboxylate. So this H plus by COH will be easily donated. Therefore they are considered as acids. Now next thing is same. Now I am going to increase the pH. We will imagine, since COH is in carboxylic acid form, this condition should be under acidic pH. It should be under acidic condition where outside H plus is more. Therefore, carboxylic acid will not be in carboxylate form. It will be in carboxylic acid form. Right? Because already H plus is there surrounding. So it's not going to release the H plus. It will hold the H plus with it. So therefore under acidic condition, this is the structure of amino acid. This is the structure of amino acid. Ammonium is not considered as an acid. It will be considered as sometimes base, or I can tell it's a very weak acid. Why? You will come to know. So now this is under acidic pH. Now slowly I will increase the pH. What do you mean by acidic pH? Where pH value should be equal to less than 7, right? Then it is called as acidic pH. That's what I have mentioned here. Now slowly I will increase the pH. What do you mean by increasing the pH? I am going to decrease the H plus concentration, right? So please remember, pH is equal to negative log of H plus concentration, right? So as the H plus concentration increases, negative sign is there, so pH value is going to decrease. As the H plus concentration decreases, since negative sign is there, pH value is going to increase. Do we agree? So due to the presence of negative charge or negative sign here, so therefore pH and H plus concentration, they are inversely related. Don't get confused. They are inversely related. Same equation I can write it as pH is equal to log of 1 by H plus concentration. One and all same. One and all same it is. That's why H plus concentration and pH, they are inversely related. So when I am telling that there is an increase in pH means I am decreasing the H plus concentration from outside. Outside andre elli sir? Outside andre. Imagine that this amino acid is present in a container, in a solution. Now the solution is acidic pH. Now I am increasing the pH of that solution. Right? So due to increase in the pH, due to decrease in the H plus concentration outside, now this carboxylic acid will release its H plus to maintain the equilibrium. To maintain the H plus concentration, it will going to release its H plus. Now due to that, what will happen? Carboxylic acid will become negatively charged. Carboxylic acid will become negatively charged. So now we will imagine this pH is nothing but neutral pH. That means where pH will be equals to 7. pH will be equals to 7. So less than 7 equals to 7. That means pH value has increased, right? So pH value is less than 7 here. But pH value is equal to 7. That means here pH value is more. pH value is more means H plus concentration is less because they are inversely related. So due to that, carboxylic acid will become carboxylate. Next, once again I will not stop here. I am going on increasing the pH value. That means I am going on decreasing the H plus concentration in the solution where amino acid is present. Now what will happen? Another H plus will come out. Another H plus will come out. It came from where? Which molecule or which atoms has given the H plus? Which is that functional group which is donating the H plus? Because carboxylic acid is already donated the H plus. Now who else is there? Forget about R. We are not talking about R here. So other one will be NH3 plus. It will donate its H plus. Now it will become NH2 CH COO minus R. Right? So all the three are the structure of amino acid under different pH. That's all. Under different pH. This is at basic pH, where pH will be greater than 7. pH value will be equal to greater than 7. Got my point? So that's where I can write three types of structure for an amino acid. One is at an acidic condition, another one at neutral condition, and another one at basic condition. Now I will make a point. You should listen to me carefully. This structure, if I would have written like this, as a PU students, we don't know. Evaluator might think that okay, fine, we'll give the marks. But if you ask me, this is wrong. Totally wrong structure what you have written. Where it is wrong? Already NH3 plus has donated H plus before carboxylic acid. How it's possible? It's impossible task because carboxylic acid is the one which will donate the H plus very first compared to this. Right? This will donate its H plus only under basic condition. So therefore they are considered as basic functional group. This is acidic functional group. Do you agree? So due to that reason we have the basic functional group and acidic functional group concept. Fine? So if you write any one of these three, don't ever write that one. That is wrong. So if you write any one of these three structure, if the question is write the general structure of amino acid, you can write any one of these three. No need to mention even pH. But if they ask, write the structure of amino acid at body pH, then you have to go for this. Because body pH will be somewhere around 7.2 to 7.4. Body pH in the sense I am talking about blood. So what is the pH of our blood? It will be 7.2 to 7.4. That means almost neutral only. So therefore this will be the structure of amino acid at blood pH or body pH. Especially biology students, you should remember. But even for computer science also, because you people are studying now chemistry, which is applicable for both. Right? So this is the general structure. Now if you observe, at acidic pH, what is that charge which is present on the amino acid? Under acidic pH, what is that charge present on the amino acid? Anyone? Thinking R does not have any functional group. But we have many amino acid where R is also having carboxylic acid or amino group. But we don't consider that. That is not there in your syllabus. So considering R or forgetting R, now tell me what is the charge on the amino acid under acidic condition? Anyone? Everything I have written on the board. What is that charge present on the amino acid under acidic condition? Any one of you can tell me. Whatever I have written on the board, whether it is visible? Okay. So tell me what is the charge on the amino acid under acidic condition? Oh, I got the answer. Very good, very good. It is positive charge. Absolutely correct because of this one. No other molecule or atom they have any charge. So therefore, under acidic condition, amino acid will have the positive charge. Under basic condition, what is that charge? Under basic condition, charge will be negative. Right? Under basic condition, charge will be negative. Yes, under acidic condition, it will be positive. All of you are correct. Okay? But at the same time, under basic condition, same amino acid will have the negative charge, which is due to carboxylate. Now, if you observe, what is the charge on the amino acid under neutral condition? Any one of you? What is that charge present on the amino acid under neutral condition? Anyone? Okay, Rohan, why that question mark? You are absolutely right. It is neutral. Okay, it is neutral, not question mark. Neutral. Neutral. Why I am telling neutral? Because equal amount of positive and negative. Right? So net charge is equal to 0. When equal amount of positive and negative is there, net charge will become equal to 0. So that's what? Net charge is equal to 0 under neutral condition. Now I am telling very, very important point. This is nothing but Jupiter ionic structure of amino acid. Jupiter ionic form of amino acid. Fine. So that's where we have the Jupiter ionic structure of amino acid. Yes, Sumati, net charge will be equal to 0. Yes, Manjunath, there are charge, but they are equal, positive and negative. So therefore, net charge will be equal to 0. Fine, very good. So that is called as Jupiter ionic form. This one many times they have asked. Write the Jupiter ionic structure of a amino acid. One mark question. Or write the Jupiter ionic structure of a glycine. One mark question. Many times. If they have asked the glycine, if you write R over here, then you are going to get 0 marks. Rest everything might be perfect. But question was about glycine, but you have mentioned R. Then you are going to get 0 marks. Because for glycine, R is nothing but hydrogen. Right? For glycine, R is nothing but hydrogen. First try to see what has been asked in the question. Since they have asked about glycine, whatever I am writing now, that is Jupiter ionic structure of glycine. Don't ever mention R here. It should be H only. So that's where I am having the Jupiter ionic form of glycine. So this is Jupiter ionic form of amino acid, a general structure applicable for all the amino acid. All of you have understood? Now, if someone asks you, define the Jupiter ionic form of a molecule, then you should tell that Jupiter ionic form of a molecule means where the net charge on the molecule will be equals to 0 due to the presence of equal amount of positive and negative charge. Due to the presence of equal amount of positive and negative charge. That is very important. Charge will be equal to 0 when there is no charge also, right? But here charge is there, but they are equal and opposite. So therefore net charge will be equal to 0. That's how you can define the Jupiter ionic structure. That's where you can write the general deuterionic structure of amino acid and general deuterionic form of glycine. These two questions has been repeated many times in your exam. Even for competitive exam it will be help you out. That is one thing. Now listen to me carefully. Another word here is isoelectric point. Another word here is isoelectric point. It is also related to deuterionic structure only. Now, isoelectric point means where I am talking about the pH. It is a value. Isoelectric point is a value. Value of what? Value of the pH. Now I will define. Isoelectric point is the pH at which a given amino acid will be in its deuterionic form. Once again I will repeat. Isoelectric point is a value. Value of what? Value of the pH. Now I will define. Isoelectric point is the pH at which a given amino acid will be in the deuterionic form. It will vary. Don't imagine all the amino acids will be in deuterionic form at neutral pH. No. But in your syllabus it is not there. But we have amino acid like acidic amino acid, basic amino acid, aromatic amino acid, neutral amino acid. 20 amino acids we have different category. Right? So based on their acidic amino acid or basic, based on their R group, their isoelectric point will vary. But don't get confused. Remember that at neutral pH there is a deuterionic form. So in general we will go with that and we will tell that isoelectric point is the pH at which a given amino acid will be neutral or it will be present as deuterionic form. All of you have understood? Any doubt? So that's where I have written the 3 structure of amino acid. Right? That is one thing. Now, next time, whenever I will be writing, I will go with deuterionic structure only. Instead of writing any other structure, I will stick on to any one of these 3. So, and I will go with the deuterionic form. Right? So, in that case, if I am writing the deuterionic structure of amino acid, that's where I will write it as H, COOH, NH3 plus, okay, deuterionic form I should write, right? See, I made a mistake. So it should be negatively charged and R. Okay? So in organic chemistry, you should remember that a carbon attached to carboxyl group, not only here, anywhere, a carbon attached to, Manjunath has written acid is equal to 2, base is equal to 3, neutral is equal to 15. So, you are talking about amino acids. Yes, carboxylic acid containing amino acid will be glutamic acid, aspartic acid. Yes, base histidine, asparagine, glutamine, lysine. Bases are more, Manjunath, not 3. They are more. Then comes the neutral. Fine. That is fine. We will not go in detail. Okay. So that's where we have the amino acid. Now, a carbon next to carboxyl group, they will be having, or they will be called as alpha carbon. Do you agree? It's in organic chemistry, not only applicable here. It's applicable everywhere. A carbon attached to carboxyl group will be considered as alpha carbon, not a number. I am going with alpha, beta, gamma. I am not going with the numbers. So that's where I have the alpha carbon. So therefore, amino acids will be called as alpha amino acids. Why? Because amino group and carboxylic acid both are attached to alpha carbon. So therefore they are called as alpha amino acid. Fine? All of you have understood? Now based on the carbohydrate topic where I have discussed, you should tell me whether alpha carbon of an amino acid, it is a symmetric carbon. Any one of you. Whether alpha carbon of an amino acid, whether it is a acidic this one asymmetric carbon. Can you tell me whether it is an asymmetric carbon? Okay, S means what? Manjunath has written that time only S. Now Varshita, she wrote SS. Okay. So now, yes, all of you are right. Not except for alanine. I will come to that. Except glycine. Alanine is also having a symmetric carbon only. Okay. So that's where they are asymmetric, because we have hydrogen, carboxyl, amino group, then R group. All are different. So therefore, it is an asymmetric carbon. It is an asymmetric carbon. Right? Now, except when I am talking about glycine, except glycine, where alpha carbon is not a asymmetric carbon, because two hydrogen attached to same carbon. Right? So therefore, in this case, it is non-asymmetric. Okay? It will be non-asymmetric. That's where we have the glycine. Glycine is the only amino acid among 20 which are not having any asymmetric center. And all the other 19 amino acids, 19, all the other 19 amino acids, they have the asymmetric center because of alpha carbon. Except glycine. Remember this. It may be helpful for your competitive exams. NEET. Fine? So that's where we have the alpha carbon and amino group and carboxyl group attached to alpha carbon. Therefore, they are called as alpha amino acid. And since all the groups are of different types, so therefore they are called as asymmetric carbon. Therefore, they are called as asymmetric carbon. Fine? All of you agree with me? Okay? So in that case, recollect whatever we have discussed with respect to glyceraldehyde and all. Now come back, recollect that one and observe here. Now based on the position of ammonia derivative or amino derivatives, this where rotation of light will be anti-clockwise. Rotation of light will be anti-clockwise naturally. They are small l or negative amino acid. That means levorotatory. That means levorotatory. Now I will mention them as L-amino acid. One thing I will make it clear, and I have already told. Not because of anti-clockwise rotation, I have not mentioned it as L. That is purely based on position of amine group here, which is on the left hand side. Because of that, L-amino acid. But since rotation, plane polarized light will be rotated anti-clockwise, that's why they are levorotatory in nature. Don't write levulose. Levulose is not applicable here. Levulose is applicable only for sugars, right? So here L-amino acids are levorotatory in nature. That one you should remember. Fine? So when it comes to another one, stereoisomer, where amine group will be on the right hand side. Rotation of light will be clockwise. So therefore they are dextrorotatory, which can be called as D-amino acids. Which are called as D-amino acid. Now, Don't ever mention L-glycine. Don't ever mention L-glycine. Why I am telling like this? We don't have L-glycine, D-glycine. All other amino acid, yes. But for glycine, it is not applicable. Why? Because no asymmetric carbon. Fine? But for all the other amino acid, we can tell L amino acid and D amino acids. Now listen to me carefully. In the nature, in a biological system, when it comes to carbohydrate, we have the D type of carbohydrate. We have D-glucose. If you remember, sucrose, D-glucopyranose, D-fructofuranose. If you come to lactose, it was D-galactopyranose, D-glucopyranose. If you come to this one, mannose, D-glucopyranose, right? So that's where we have the D-glucoses or D-fructoses. So D form, listen to me carefully. D form of amino acids are, sugars are present in the biological system. But when it comes to amino acid, it is the L form which will be present abundantly in the biological system, not D form. All of you have understood? When it comes to carbohydrates, we have D form. But when it comes to amino acid, it is L form, which are abundantly present in the nature. Especially if you go with the humans. In our body, in our tissues, we have D type of amino acid, L type of amino acid, which are involved in the proteins. D form of amino acid is not there. Fine? So all of you have understood? Okay, fine. There is one question. What is that? Deuterionic means it shows amphoteric in nature, then react with both acid and base. Yes, absolutely correct. Right? So they can be considered as amphoteric form. Fine. But when it comes to amphoteric form, if you are talking about reaction, all the amino acid can show that. Not only deuterionic form, any form of amino acid they can show the reaction both with respect to acid and base, because all of them, all the form of amino acid, they have the acid and base in their structure, right? So it may not be appropriate when it comes to the reactions. Fine, but as amino acid, fine, since they are having both acid and base, they will show the reaction for both, related to acid also, related to bases. Fine. But since there is equal amount of positive and negative charge, therefore we are calling them as deuterions. Fine. Manjunath, whether you got the answer? Because with respect to reaction, at any pH they can show the reaction, because at any pH they have both base also, acidic group also. If we are talking about the reactions, so that's where we have the L form of amino acid which are abundantly present in the nature. All of you have understood this one. It is a bit important, but please remember, whatever I have told, it will be important for your competitive exams. But the deuterionic structure or general structure of amino acid, they have asked many times for your board exams also. So you have to know all these things. Fine? Now we will move to next one, another 10 minutes or 5 minutes. So when it moves to, we will move to the next one, where now I will be talking about peptide bonds. I will be talking about peptide bonds. Okay. Now when I am talking, before going for that, another one is that you can discuss 19 amino acids. Sumati, if I start discussing 19 amino acid, this whole week it will go there, because aromatic amino acids are there like tryptophan, tyrosine, phenylalanine. Then we have neutral amino acid like alanine, valine, isoleucine. What I meant to tell you is, if I start discussing about them, then you will be expecting the structure. If I give the structure, then you will forget which is important structures. So Sumati, for time being, will not discuss that one. If you want any questions about that one, you can ask at the end of the class, no problem. But all the 19 amino acid, if I ask discuss here, it will maybe consuming the time, and which is not required for your exam point of view also. But knowledge point of view, yes, you can gain the knowledge, no doubt. I will not stop for that. Fine? But when it comes to peptide, before going for that, another important thing I forgot. We have essential and non-essential amino acids. Essential amino acids and non-essential amino acids. I think some of them, among the 19, Sumati, some of the amino acid name will come over here. Don't worry. Okay? So essential amino acid and non-essential amino acid. Now, before, this is not related to peptide bond, but this is also important for your exam point of view. So essential amino acids are those which are not synthesized in our body. As a human beings, we think we are highly evolved, right? But if you take some of the biosynthetic pathways, metabolic pathways, microorganisms are more efficient. They don't demand anything from outside. Basic things you provide, they will create their own food, right? But when it comes to human beings, we depend for so many things for the nature. So to give some of the example, we don't have essential amino acid when it comes to bacteria, because they can synthesize all the amino acid. But when it comes to humans, we have essential amino acid, non-essential amino acid. Because among the 20 amino acid, nearly 9 amino acid we cannot synthesize. We are dependent on the food for that purpose. That's what I was telling, egg white. It's a high quality protein. That is because it provides all the essential amino acid. Therefore, when you are eating those food items, then your body will take or it will get all the essential amino acids so that it can produce the protein. Now I will make one important statement. In our body, almost all the proteins, they require all the 20 amino acids in different combinations. If any one amino acid is not there, then that protein may not be efficient in their function. Whether I am clear? Whether I am talking about enzymes, whether I am talking about muscle proteins, whatever it is. All these proteins, they will be requiring almost all the 20 amino acids in different combination. That varies from proteins to protein. So therefore, all the amino acids should be there in your body. You should provide all the 20 amino acids. You cannot tell that now I am providing 15, adjust with 15. No, it will lead to the problem. Fine? So therefore, all the 20 amino acids will be required. So in that way we can classify essential, non-essential. What are essential amino acids? Essential amino acids are those amino acids or group of amino acids for which we are dependent on the food or nutrition. Or another way around you can tell that essential amino acids are those which cannot be synthesized by our body. That is also fine. That's why they are essential, we require. Naturally, non-essential amino acids will be opposite. Non-essential amino acids are those which our body can synthesize. Or other way around. Since our body can synthesize, we are not dependent on the food. We are not dependent on the nature. We can only synthesize. So therefore they are called as non-essential amino acid. Fine. Now if you want to remember the example, I will give one phrase. Okay. So that will be called as HILLVMPTT. Hillwind. That is nothing but hillwind. M is silent. Hillwind. So if I want to expand these letters, H stands for histidine. Sumati, she was asking, 19 amino acid, right? Because I have discussed about glycine. Histidine is a basic amino acid, abundantly present in hemoglobin. Remember that one for biology students. So that's where we have histidine. Then comes I stands for isoleucine. Please remember, amino acid can be represented by single word or three-letter abbreviation. So we have different type of representation for a amino acid. No need to write histidine completely. Histidine, three-letter abbreviation is his, not her. His, H-I-S. Okay? So the single letter will be H. So isoleucine, I-L-E. Ravikant has written. Very good. I should be capital. So that's where we have leucine. Then another L stands for lysine. Now here only I will tell some of the example. Someone were telling basic amino acid. Histidine, lysine, a very good example for basic amino acid. Histidine and lysine. They are the very good example for basic amino acid. Then leucine and isoleucine. They are very good example for neutral amino acid. Same way, V stands for valine. M stands for methionine. Okay, a sulfur containing amino acid. Methionine is a sulfur containing amino acid. We have total 2 amino acids which have sulfur in their structure. One is methionine, one is cysteine. Both are having sulfur in their structure. No other amino acid they have the sulfur. Okay, so that's where we have the methionine. P stands for phenylalanine. P stands for, PH is actually 3-letter abbreviation, phenylalanine. Okay, so T stands for threonine. And this another T stands for tryptophan. Another T stands for tryptophan. Now I will tell these two are example for basic amino acids. So here there are another 2-3 are there, and I will represent here only. Isoleucine, leucine, valine and methionine. They can be example for neutral amino acid. Even methionine is one of the example for sulfur containing amino acid. Okay, methionine. When it comes to threonine, it is a amino acid which is having OH group. Another one is serine, which are not presented here. Threonine and serine are OH group. Single letter abbreviation is T. Okay na? Now here tryptophan, single letter abbreviation is different. To make you understand, I have written TT. Okay? So tryptophan single letter abbreviation is actually W. But anyway, you will not confuse. So this is an example for aromatic amino acid. This is aromatic amino acid because they have the indole group. Indole is an organic chemistry. It is a heterocyclic compound where it is having 2 rings. One is benzene ring and another one is heterocyclic. That's what it is called as indole ring. So aromatic amino acid. Phenylalanine, another example for aromatic amino acid. So these are some of the acids which are essential, which our body cannot synthesize. So approximately 9 should be there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes, 9 amino acids. They are essential. Right? Now, rest 11. That one we can synthesize. Letter code are present. No sir. I am not getting. Why you want a letter code? You are getting confused. We will not go into so much depth. It's there in your syllabus. I don't think it is there. Even deuterium structure and general structure is there. You don't have that much detail. If you want, I can tell, but I don't think it is required. Single letter abbreviation or 3-letter abbreviation. Fine? Because they have different single letter. For example, asparagine, N. aspartic acid, Q, like that it will come. Why you want all those things? We'll not discuss that one here. Okay, if you want, okay, fine, because it is not there. Okay, Manjuna, that's why I am telling. I am not discouraging you people. It's good if you learn as much possible, but I don't think single letter, this one and all, it is there or it is required for you. Because for some amino acid, it is applicable, their first word itself will be single letter word. But many amino acid is not there. They are given different, right? Glutamic acid and all, it is D. And in glutamic acid name, nowhere you will come across D. So therefore, we will avoid the confusion. Okay? So now I will come to the peptide bonds, or I will discuss it in the tomorrow's class. But any doubts? No, I am not discouraging anyone, because some of the people have asked rest of the 19 amino acid. That's fine. And even Manjunath, you had asked letter code. Yes, that is there actually. But when you go for higher studies, okay, it may not be required here. So that's why I am not telling that one. Others should not get confused. But I am not discouraging any one of you. Okay, any doubts? Okay, in that case, I will stop here. So tomorrow we will finish the protein topic. Okay, peptide bond, then types of protein it is there. We will finish it off. Then we will move to the nucleic acid. Then last one is vitamins. Okay? Okay, fine. Thank you. Take care.